Hello guys. So today the question which we are gonna solve is minimum falling path sum, which is today's Leetcode daily question. So basically we have been given a 2D matrix and we have to find the minimum sum of any falling path through this matrix. So now what is a falling path? A falling path basically starts at any element in the first row, like we can start at either 2, 1 or 3, and it ends at the last row, that is 7, 8 or 9. And we have to find such a path such that the sum of the elements is minimum, and also the condition given to us is that we can either move, if we have to move to the lower row, so we can either move to the lower left, lower right, or lower one, or the lower element. So for example, from 1 you can move to either 6, you can move to 5, or you can move to 4. So this is the condition given to us. So now basically there are three approaches to solve this problem. So we will be solving. First one is basically a recursion, and with recursion comes DP. So recursion plus DP is first solution. Second one is simply a DP solution, and the third one is basically a space optimized solution, wherein we will be using two O of n matrix instead of using a 2D matrix. So now let's come to the recursion one. So the recursion one is simply, so first, I will initialize a DP matrix of a 2D DP matrix, and then for each element of the first row, so the each element of the first row, I will call the recursion function, and the recursion function will return some certain value. So I will compare it with minimum and store it in minimum. So minimum will have a maximum value for time being. In recurse function, we have what I will do is I will store the minimum path of each function and I will simply put it in the DP matrix. So let me explain you this in the PowerPoint in the notepad. So this is the function of the recursion. So basically, putting we have this 2, 1, 3, 6, 5, 4, 7, 8, 9 question given to us, and we have a DP matrix initialized to 0 initially. So now now for 2, as I said, for each element of the first row, I will call the recursion function. So now 2 will call the recurse function. Now the first is basically the first part of this recurse function is simply we are checking whether the element is not out of the matrix. So it is in the matrix, so we will continue. Now second is I will check whether it is the last row or not. So it is not the last row, so I will simply skip this. Now next, if I will check if DP array has some value for this I and j element matrix. So it doesn't have for now since it is 0 currently. So now I will move to the next part. So in the next part, what I am doing is basically I will move to the low. I will check for the. I will move to the next part, that is the lower element, lower row. I will. So let me explain you through this. So from 2, I will move to 6, since we are allowed to move to the bottom left, and bottom right. Now bottom left is out of the matrix, so it will simply have integer or maximum value as I have written over here. And from 2, I can also move to 5. So now let's first evaluate 6. From now 6, you can move to 7, and you can move to 8. So you can also move to 8. Now since both the element is the last row, as per our function return over here, we will simply return a maximum of, we will return the matrix ij itself. So now 7 will return a 7 itself, and 8 will return a 8. Now 6 have a choice. 6 has to pick the minimum of both the elements, that is 7 and 8, and it will store in the DP array the minimum of bottom right plus the sixth element, that is it will store 7 plus 6, that is 13 in the DP matrix. So for now in the DP matrix we have for sixth element we have 13. Okay, so we have a 13 over here. Now 5 will also do the same thing, but only thing is that 5 have three choices. It can move to 7, it can move to 8, it can move to 9. So it will choose the minimum of the three. So from 7, 8, 9, 7 is the minimum one, and so it will store 12 over here. That is minimum of 7, 8, 9 plus 5. That is 12. So 12 will be stored here over here. 4 also has a choice of 8 and 9, so it will choose 8, and it will store 2 over here. It will store 12. So now, so 4 will not be evaluated now, because from 2 we can move to only 6 and 5. So now 2 has 13 and 12. So it will choose 12 from it and it will store 14 over here, and it will send this 14 to the minimum. And now for minimum will have in the main function, minimum will have a 14. So now minimum is equal to 14. So now we will move to the next element, it is 1. So now 1, from 1 we have, from 1 we can move to 6, 5 or 4. Now 6 already has a 13 element. So there is, this is where DP comes into use. Now 5 will also have 12 in its in itself in the DP1. Now 4 is not yet initialized, is not yet evaluated. So now we will move to 4. So now from 4 we can move to 8 or 9. So it will simply store a 12 over here, because the minimum of 8 and 9 is 8, and 8 plus 4 is 12. So now one has a choice of choosing from 13, 12 and 12. So minimum of all the three is 12. So 12 plus 1 is 13. So it will store 13 over here, and it will also send this 13 to minimum. Now minimum initially has 40, it has become 14, but 13 is less than 14. So minimum will become 13 over here. So now we will move to the next element, is 3. Now 3 has, now 3 is, we can move from 3 to 5 and 4, but at that element we have DP, in DP array we have 12 and 12. So we don't need to go any further. So 12 plus 3 is 15. So 15 will be stored and 15 will be sent back to the main function. Now since 15 is not less than minimum, that is 13, so 13 will be the answer, and at the end we will simply return the minimum one. So this is how the recursion plus DP works. As you can see, we have just send the minimum one at the end. So now we will move at the tabulation part. So now coming to the DP, to the tabulation part. So in tabulation one, again I have initialized a DP matrix of a 2D array, a 2D array DP matrix. So now what I have done is I have simply copied the last row of the matrix given to us to the DP matrix. So as you can see, these 7, 8, 9, 7, 8, and 9, that is the last row, has been copied from the original matrix to the DP matrix. So now this is the main function. So now coming to the main function. So now for what we are going to do is we will start evaluating from the second last row. That is, we will be evaluating from this row, and we will keep on going up. So this is a bottom up approach. So now what we're gonna do is we will suppose now in I have at this second last row, that is this element. So here I have two choices. I have 7 and 8. So now what I will do is I will pick the smallest of them, as we did in the recursion part. So I will choose 7 and 8 minimum, that is 7, and I will place minimum of 7 and 8, that is 7 plus matrix I of j, that is as we saw in the question. So basically this element was 6. So 6 plus 7, that is I will again take over here 13. So 13 will be stored in the DP matrix. So 13 will be stored over here. Similarly, in the next, in the second last row, second column, I have 7, 8, 9 as a choice. And again, I will start filling this, and I will pick the minimum, that is 7, 7 plus the element which was there in this, in that row, that is 5. So 5 plus 7 is again 12. So I will simply write 12 over here. So it is similar to what I taught in recursion. So here just we are using only a 2D matrix, but the only difference is that instead of using recursion, we have just filled the last row. We have just shifted the last row of the matrix to the DP array, and just we are doing in a tabulation format instead of recursion. So now I will complete this matrix. So as you can see, I have filled the 2D DP array using the same logic which I explained in the recursion, and finally we get this. So basically, this part does the part of filling the matrix, and similar to so now what changed from recursion is that if I equal to 0, that is if we are evaluating the first row, I will simply check the I will compare the minimum with the element of DP, and I will show the minimum. So like if we are at I equal to 0 at 40 at this element, that is this. So here I will, in each element of the first row, I will check and store the minimum. So for minimum of all this is 13, so 13 will be written over here. So this is how it goes in tabulation. So now let's move the last approach, that is O of n space complexity. So this is the last approach, that is O of n space complexity. So as you can see that we generally don't require the entire matrix, entire 2D matrix. We require only the next row. Since we are using only, we are filling the tabulate the 2D matrix by uh, uh, by going to the next element, next row itself. So we will simply have a next array, that is a 1D array of matrix 0 dot lengthless. Number of columns will be same as the original matrix, just it will be one 2D, one D array. And then what I will do is I will simply store I will simply store the last row in the 1D array for now. Okay. So now I will again do the same as the tabulation. That is, I will first I will start evaluating from the second last row. So now in second last row, what I will do is I will initialize a new 1D matrix, that is 2, that is a DP array, 1D array. So now again what I will do is I will initialize left, right, and down. So so if j plus 1 is less than 0, so I will put right equal to next of j plus 1. That is, I will the bottom right will be not, it will not be from 2D matrix, but it will be from the next 1D array. So since the last row was in the next 1D array, so in the right will be next of j plus 1. Similarly, the left one, that is bottom left one, will be in the next of j minus 1. So, and the down one will be simply in the next of j. So, dp of j, that is the new dp which we initialized over here, will have a dp of j equal to minimum of left, right, and down plus matrix of ioj, similar to tabulation. Just the difference is that instead of accessing dp of I plus 1 j and I plus 1 j plus 1 I plus 1 j minus 1, we are just doing it with the next 1D array. So we will be storing it in the DP, and then at the end, the thing is that we will store next in DP. That is the current DP which we calculated over here will become next. Will be stored in the next 1D array, and again I will in the upper one row I will again initialize the DP array, and I will do the similar thing, and I will again store that element in the that entire row in the next. So this is how we will space optimize it. So that means that we are just changing the next 1D array, and we don't require the entire 2D array. And when I equal to 0, so I will again, just as tabulation, I will simply check the minimum and store the minimum element. So this is how all the three approaches grow. So I have submitted all the one that, like, this is the space optimized one. This was the tabulation one. This tabulation one was also accepted, and this is the recursion plus BP one. So this all these three approaches were accepted successfully. So this is how it goes. So I hope you liked the solution video, and if you liked it, so please do like and subscribe. And thank you for being with me.